load balancer, right? And one of the very important load balancer, guys, that mostly we wanted to use always is ALB, application load balancer. Okay, one of the cool thing about this load balancer is there has a capability to understand the application layer protocol. Okay, especially the HTTP. Okay, and because of this, we can create a multiple rules. Based on this rule, we can route our traffic to particular group of computers that is called target group. Okay, that is one of the great capability of the ALB. That's what I explained you in my last class in very detail. Okay, but one more point, guys, that can be a drawback of ALB. Can be a drawback of ALB would be something like this. If you talk about the OSI layer of networking, and I told you guys there's a multiple layer 1, layer 2, layer 3, layer 4, 5, 6, and 7. Okay, any program that has a capability to read your packet or network packet. So typically, guys, every packet has all 7 layers of the networking. They will go via some physical medium, maybe by Wi-Fi, radio waves, or electric current. Okay, or either they have some IP address. This is called IP header, TCP or UDP header, HTTP header. So every packets, or I can say the network packets, have all the 7 layers they go through. Okay, they go through all the 7 layers, right? And now it doesn't matter they are TCP protocol or UDP or any other this kind of protocols, whatever they use. Almost they go for all the 7 layers. Okay, but any program who wanted to read layer 4, first they have to read layer 3, then they can reach to layer 4. Any layer who wanted to read a packet layer 7, so they have to read all the layer up and up and up. They go and then finally they reach to layer 7 and they read the layer 7. So anybody who have done anytime a network programming or network socket programming, they might know this. A point is, more deeper you go in the packet, more data you have to read, more time it's gonna consume for program to read. It means if your program is going to the application layer in the packet, it takes much time. Okay, and when they take much time, it means the overall time of reading the packet, because till the time you don't read the packet, how can you create the rules on that particular application layer? So this program, guys, is I'm talking about the application load balancer. So in application load balancer, guys, whichever program they are running, okay, for this they have to go inside and deep into the packet. Okay, and almost in every packet, and every time they go in deep in the packet to the application layer, so overall reading the packet will take a lot of time, and then only they can see the rule, and accordingly they route the traffic here or there. Okay, so so technically what I'm trying to tell you here is, in application load balancer, right, it take a lot of time always to read the packet. That makes this application load balancer on balancing the balancing the load, okay, become it get a lot of latency, I can say. Latency means the delay. It will impact the performance of the networking and overall performance, I can say. So here the latency is very high comparative to other, even though they AWS make this thing very super faster compared to the other product in the market, but technically if you try to compare, this latency is very high, right? High means more delay they have. Okay, that is a reason. What they come up with, they come up with one more type of load balancer, where they intentionally make that load balancer latency very low. means quickly they can read the packet and quickly they can route the traffic according to the target group. Okay, so if you want performance in the routing or the load balancing, or if you want latency to be very, very low, if you think there's a huge traffic is coming, maybe hundreds and thousands and millions of requests per second is coming, directly using the ALB is never the right choice. Okay, to have the low latency load balancer, then the NLB come in play, network load balancer come in play. Okay, the cool thing of network load balancer is they work at the network layer, that is mostly the layer number 3 or sometimes layer number 4 also. That is one of the cool thing of the network load balancer. They won't go to the application level. Okay, and because they won't go to application level, so any HTTP header kind of rule you can't create in an NLP. That is one limitation, right? But that is not the main motto of the NLP. NLP they created in such a way that so that you don't have to go more deep into the into the packet. So just by checking at the layer 3 or maybe sometime layer 4, we can check the load balancings, right, and balance the load according to the respective target computers. Okay, there the NLP guys come in play. So NLP is again one kind of load balancer. The main motto is, if you think you have a huge load, okay, if it's again, let me use the EC2. If you think you have a huge load and you want to serve these load, like maybe thousands of millions of requests coming per second, this kind of load you have, then NLP is the great choice to use. So this is the NLP I'm talking about. Has to use. Even though if you see from the diagram, in ALB they are hitting HTTP, HTTPS means application layer. In NLB they are hitting UDP and TCP means the transport layer or network layer. Layer 3 and layer 4 they are hitting over here. Okay, that's what we can use. But again, it is for ultra high performance. All right, that was the things handling millions of requests per second while maintaining the ultra high speed. That is the main use case of the NLP. Okay, but now the point is, do you want speed?
Hi, I'm Rob Cram, and today
you can't go for the rules and create a rule what I explained yesterday. Based on the rule, you want to serve the traffic here and there. Okay, but if you want to serve the rule, take a smart decisions, okay, then NLP you can't use. So that is a reason the good practice is normally it would be something like this. Normally what happened when we have the client, so the good architecture would be something like this, right? We put NLP in the front of client directly. So client is hitting to the NLP. Okay, and NLP has a capability to take millions of requests per second. They can take all the requests, and behind the scene NLP will load balancer the traffic to different ALB actually. Now here the ALB application load balancer can be used. It is not compulsory. We can connect NLP directly to our instances the way I see it till date, but this is a great design we can plan. Okay, and in the ALB we have multiple target groups. So we have target group the way I explained yesterday, or I can say last class. We have target group for search, we target group for mail. In the target group we have multiple instances running. In target group we have multiple EC2 instances running. Okay, so it will be something like this. So this target group is having multiple instances. This target will have multiple instances of mail server, and this can be connected by this, and this. Okay, similarly this can be connected by this, and this. Okay, that would be a better design. In this case, everything would be possible. Okay, the first thing that is possible is if millions of requests come up, one NLP is more than enough to take these requests rather than discard any of the connection from the client. Okay, after having this request, NLP further distribute the load to different ALB. Now ALB has a capability to read application layer level protocol, and based upon the application rule, they will further redirect the packet here or here, the respective target groups. Okay, so let's say we have 300 requests coming. 100 requests go here, 100 will go here, and 100 will go here. Okay, and normally, guys, typically, if you compare, ALB normally have, as I'm giving a rough example number here. ALB has, guys, normally latency of 300 millisecond, and NLB normally has latency of less than 100 millisecond. It means out of 300 requests, let's say NLB 100 and 300 requests, then 100 these guys can be handled. Okay, so I'm talking about latency. It may be more or less. I'm just giving a rough number here, just to compare. Okay, latency means delay. So this much time ALB will take, and this much time normally NLB will take. So accordingly, you can test your environment. You guys can maybe get less or more. Accordingly, you can plan number of ALB behind the NLB. Right? So this is the idea. So otherwise, NLB is mostly the load balancer to give the ultra high speed performance for the client. And because this is a great architecture we have, okay, so that is a reason, guys. Okay, NLB, AWS has given a capability. In NLB, we can use our own EIP. EIP, guys, you know, it is a fixed IP address. In ALB, there is no way to fix the IP address. ALB, whatever IP is given by AWS, is AWS assigned IP that can be changed. But in NLB, okay, we have a capability to assign a fixed static IP that won't change. What is the benefit of this? Mostly what happens, guys, in the real world or maybe in the corporate world, okay, let's say this is the corporate enterprise. They have a lot of workstation in the corporates. And normally what they have firewall, corporate firewalls. Okay, and in the firewalls or maybe in the sometime proxy, they have the rule, any traffic going out somewhere else, we won't allow. So normally they have to write and allow some limited IP addresses. So if you use ALB and IPs keep on changing, in this case, anybody from this corporate world try to connect, IP changing, they won't be able to connect. The firewall or the corporate firewall block them. Okay, so normally what we have to do, we have to again every time contact to the security team, and they will allow that particular IP address if we directly connect to the ALB. But in NLB, IP is fixed, and this IP we can give to the firewall team or the security team. They will allow this IP address for the corporate, so that anybody in this corporate world, they want to go out, connect to this NLB, they can connect. That is also one of the great use case of the NLB that is not possible in ALB. NLB, we can give the fixed IP address. And why they give this option in NLB? Because this is what the normal great architecture we have. Okay, we don't allow, it's not good practice, I can say, to directly give the ALB access to the public world. Why? Because of the latency, extra latency they have. Otherwise, you can do it the way I showed you in my last class. But I'm talking about here the great practices and the best practices according to the need. Okay, so that's what, guys, the idea is. So let me show you very quickly even though this is what the NLB talking about, ALB you can use, or maybe you can directly go give the instance access also. But if you want to create the NLB, just click on the create, give the NLB name, let's say my NLB load balancer. Okay. Do you want to make it internet facing? Use it, have the IP address, put in the VPC. All the consoles, guys, are the same, what I explained till date. I want to make the NLB my public, right? And guys, here they have option IP address. Now, either you can take the IP from AWS, that might be changed, or you can take the elastic IP. Okay, so in my Mumbai region, I don't have the elastic IP. I go to my EC2, assign the have the elastic IP, and then assign over here. Okay, and again, same thing. Here also we can use the public, and here also we can assign the elastic IP address in this region. Okay, this option was not there, guys, in ALB. In ALB, only assign IP was there. That's what I was trying to tell you in that class. Okay, but here we have both the options. Mostly in this kind of use case, what I was talking about, we want to make the fixed IP. This come from EIP. Okay, and right now I'm taking as a AWS assign one, but you can go for EIP also. Okay, otherwise the concept is same. Here, any traffic come on TCP, guys, there's no option for HTTP here. Why? Because they are not working on application load balancer, so there's no HTTP come up. Only TCP layer they work on. Any traffic come on port number 80 on TCP, because HTTP work on TCP only. We will send this guy to target group. Okay, so let's say here the target group would be whatever you have, you can put. So I don't have any target group. Okay, because I assigned the target group in this VPC yesterday. Because that target group may be usable, but you can create target group and assign it. Okay, otherwise everything is same. Okay, so that is the guys one point. But in the target group, let me show you very quickly. When I'm creating the target group, now here we option, we can directly connect our NLB to directly to the instances the way I show you till date. This is possible if you want, or you can connect to application load balancer also. This is what we have the diagram over here. Okay, so NLB will connect to the ALB. That is also possible. Okay, so let me give my my target group name, my ALB target group. Okay, again, they connect to the port number 80. So in my application load balancer, guys, we might have kind of running with 80 port number. This is the VPC name, how to check the health, right? And next thing, let me click next. Okay, tell me the application load balancer name, or you want to add later. That will be your choice. I already have the application load balancer I created in my last class, working fine. Okay, and create the target group. Now this is what the guys diagram created. So any traffic come to NLB, there is to ALB. ALB will further distribute to the respective target group what I created in the last class. Okay, now here my target group has been created. This is called my ALB target group. Okay, but here this guy is not assigned bit to any load balancer. Okay, so he's asking to create a network load balancer, but I was creating already. So let me refresh. Now this name come up. Okay, and finally this is the summary of NLB. Now that's one thing. CLB and ALB, what I created till date, is in a free tier. This service is free for whatever the time would be, but in a free tier account, NLB is not free. They will charge you. So if you do the spectacle of NLB, so just go in the check in the NLB pricing, they will charge you that much amount. It's not free in the free tier account. Okay, so you guys, finally your network load balancer has been created, and this would be this kind of. Okay, this time maybe some of the part might fail because I have to check the security group also in ALB. You have to allow the security for the NLB or all IP address, or NLB IP address, or NLB security group. So this might, the reason it might cause the the error of connection on the health check. Okay, otherwise everything is right. Now in NLB we have this IP address. Behind the scene they assign to the AWS assign IP address, but we can make it fixed also. That's what I told you. Okay, they're still they are provisioning the system. Okay, and now after the provisioning, right, you can check the connectivity of this target instances. So these are listeners. It is connected to this particular target group, and this target group now has been assigned to the NLP that I was talking about. Okay, this status is still assigning. Health check is going on. Health registration is in progress. Okay, and this ALB, guys, this ALB what I created yesterday, okay, has been connected to this security group. So you can check the security group, what they are allowing. So the security group allow this inbound traffic. That's allow actually. So there might be not as such issue come up. Okay. So because there is an idea of NLP, nothing very technical. Okay, but knowing the right use case is very important. That what I explained to you. When they active, I'll show you it will working fine. Okay. So that is guys about NLP. Likewise, we have one more type of load balancer. Is a very new load balancer. Okay. The name is called gateway load balancer. Okay. The use case is very interesting. I'm just explaining you the use case. Okay, because this topic is actually part of your advanced networking and security. Okay, but knowing the use case is that was we require in this level of training, right? So idea is something like this. If this is the client, okay, any traffic come in, okay, let's say we have a load balancer, maybe ALB load balancer, and then we have a target group here, one target group number 2. They will send here and here depend upon the rule. Okay, so ALB is a load balancer who check the rule accordingly. They send the traffic and route the traffic in respect to target group. But this load balancer have no capability to do beyond this, and they have no capability to check any security related checks. Okay, what I mean by this, normally we know what happened when any traffic come from outside world. Okay, we don't know are they doing any kind of attack or DOS attack, okay, or denial DDoS attack, or maybe any kind of further network attacks or sync flood and other kind of attack they are trying to do. So normally what we have in the corporate world, we have a different security prevention system. This is called IPS or IDS. These kind of security tools we have, and some more security security checking tools. Okay, signature tools, multiple different tools we have. Okay, so mostly what we want, any traffic before they hit to ALB and they send it to the respective target group, I want to check does they are doing any kind of DOS attacks or any kind of security attacks. Okay, so what I want, any traffic that's come, first they go here, they check. If everything is good, then I want this can be go to my internal application load balancers. Okay, but if they feel any traffic is coming like a malicious traffic and something like this, then these tools have the capability, they can drop it and they can block also. Multiple options they have. Okay, so in this case, we have a lot of third-party IPS and IDS and appliances available. Okay, that we can use to do those kind of security measures. Okay, but who send the traffic to these guys? So here the option of gateway load balancer or GW gateway load balancer come in. So between your actual ALB, or maybe you might have NLB also in the front of this. Before ALB NLB, we have a gateway load balancer. So what they do, the traffic will be something like this. Now client will head to the gateway load balancer. Now gateway load balancer first take this traffic, send to the respective security appliances or IPS IDS appliances and devices. Let them first they check the security rules or security X rules. If they allow, then this traffic go again back to GLB or gateway load balancer, and then further process will be same exactly the way it should work. Okay, but in this case, the GLB is sending the traffic to these appliances, and they say no, this is very secure dense network connections. They block directly here. This packet won't be go to my internal network. Okay, in this kind of use cases, okay, your gateway load balancer would be the one that can be useful. This one, gateway load balancer. So they send the traffic to, this is the kind of security. No, so this one, the checklist or what are the complete security compliances, whatever you guys you have. Okay, there's also known as third-party virtual appliances. They support Geneva protocol, means they have capability to get the traffic and check and go back. So your security appliances have these kind of protocol support. They will check the security compliance policy controls, and then only they send into internal team or internal systems, I can say. Okay, so there's the GW LP load balancer is useful. It's very, very interesting. Otherwise, initially it's very harder to configure this kind of setup, to first get the traffic into my security compliances, then send to NLB and ALB was very, very harder initially. Okay, now because of this new service of GLB, this entire setup would be so much simple. Okay, right now if you try to create, would be almost the same, right? But here in the default actions, you have to send Geneva protocol gateway things. Otherwise, everything is same, you see, but you have to configure third-party appliances for security. Okay, and then you have to test your target group. Okay, for example, try to create a target group for this. Okay, then wherever instance guys you are running that has this protocol support, okay, you have to connect this where in your target group. Maybe you're running directly on the load balancer, or maybe they're running behind some application load balancer. That will be a different point, but this should have support this. So that is a part of guys of advanced security training, this topic. But at least this much knowledge is enough to understand the basic working of this particular load balancer. That's so-called GW or gateway load balancer. Otherwise, everything is same. Okay, so as there's four different kind of load balancer. I explain you everything. Okay, apart from GW, I given you the entire practical of all the load balancer, ALB, ANB, ALB and LB, GW, LB, and CLB. So all those things I explain to you in very much detail. Some of the small features also they have, I will explain you sometime. Okay, and right now, in my case, the NLB is been active already, and if you see the detail, this is active. Okay, and if you see the listener here, they are successfully connected to this ALB, and here this ALB has successfully been registered. So here it's been healthy. Okay, health check, if you check also, is healthy. Now NLB is sending traffic to application load balancer, and we can use the stick IP also, that I explained you already. Okay, so that's all. And if you go for NLB, okay, the based on guys my last class practical, if my all last instance is up and active and my target group is active, then you can use this link of NLB. Okay, and this super fast, ultra super fast to connect the instances. Okay, guys, it was actually up. As here, it was working very much fine. Very much fine. Whatever the instance they connected based upon the rules. So this is this is what I almost something I created the setup here in this level of training. Okay, guys, I think you understood the idea. And the good thing is, if you know how to do performance testing, load testing on the networking, if you belong to that particular team, right? Just check the DAG traffic on NLB, see the performance, and send traffic on ALB, see the performance. You see the huge difference gonna come up. So there is ultra fast and very, very less low latency they work on NLB. That is a good use case of the NLB. Okay, so that is one topic we have. There's some more small information about load balancers, like sticky bit and much more thing. Small information I will show you guys explain in my upcoming discussion. Right now today guys, my plan